Welcome to China Gateway. Today we're diving into something everyone's been talking about, the rising tension between the U.S. and China over rare earths. Don't worry, this isn't a political shouting match. We're here to explore what's really behind the headlines, the technology, the supply chain, and what it all means for innovators and entrepreneurs.
Yeah, absolutely. And these materials, they're critical. They connect directly to your daily life, your smartphone, the motor in your EV, the magnets and wind turbines. And then on the strategic side, indispensable for defense tech. Think F-35 jets, advanced radar systems. The stakes really couldn't be higher.
Right, so we're unpacking the real barriers here. Our mission isn't about the politics, it's more about the chemistry and the process itself. Because you read the news and the common idea is, well, China wins because they have more minerals, right? They just dig it up cheaper or faster. Is that really the story?
That's honestly the biggest misconception we need to clear up right at the start. China actually only holds about, 37% of the global rare earth reserves. Their dominance, the fact they control pretty much the whole market output, it's 100% based on a high-tech advantage, specifically mastery over the industrial process.
Wait, 37% of the reserves? But over 90% of the actual process material. That's a huge operational gap.
It is colossal. The real technological hurdle isn't the mining, digging rocks out of the ground. It's the incredibly complex chemical separation and the precision purification that has to happen afterwards. Sources often call this separation process the crown jewel of difficulty in chemical engineering. It's just incredibly tricky.
The crown jewel of chemistry. Okay, that sounds pretty intimidating. Why is it so hard to separate these elements out?
Well, because for these elements to actually work in high-performance applications like magnets or lasers, they need to be ultra-pure. We're talking sometimes 5 nines, 99.999% pure. And hitting that, it takes hundreds, literally hundreds, of continuous extraction and purification stages. If you miss that purity target, even by a little bit, the material is basically useless. You might have the ore, but without that super refined process, you don't have anything you can actually sell or use in advanced manufacturing.
Okay, so it's really the recipe.
Yeah.
And maybe decades of kitchen know-how that really matters here. But all right, let's say a country like the US has the money, and maybe they get the chemical blueprints, the perfect formula. Couldn't they just start building the factories and catch up?
That's where it gets even more complicated. That's where this technical advantage slides into what you might call industrial craftsmanship. It's way more than just having a patent or a formula on paper. It's about decades of accumulated data, proprietary process knowledge, and just constant trial and error. That formula doesn't tell you exactly how to tweak the temperature or pressure in stage 257 when something fluctuates slightly. That comes from running the process thousands and thousands of times.
That sounds like a really long and probably very expensive learning curve. But couldn't things like, IP laws or aggressively hiring the right chemical engineers bridge that gap faster than, say, 15 years?
You'd hit a couple of big roadblocks almost immediately. First, the patent landscape. It's just vast. China holds something like over 50,000 patents related to rare earth materials. The US, around 3,000, and a lot of those are for older processes that maybe don't scale well or aren't efficient anymore. Second, even if you magically solve the IP issue, you still need the whole ecosystem. Imagine the US starts a refining plant today. Great. But where do they get the essential upstream stuff, like the highly specialized extraction reagents needed for that purification?
Let me guess.
Yeah, you guessed it, primarily. Those are made, scaled up, and supplied from China.
Wow, so you're literally dependent on your main competitor for the crucial ingredients you need to even try and compete. That's a serious industrial cluster effect.
Exactly. And let's say, even hypothetically, there's a massive technological breakthrough tomorrow morning. Getting the sheer capacity online takes years. You're looking at minimum 3 years just for permits, building specialized equipment, construction, training people, and dealing with all the environmental hurdles. Because remember, this processing uses strong acids and often involves radioactive byproducts. It's not clean or easy.
Okay, let's talk about that scale, because it gets kind of mind-boggling when you look at the sheer volume of raw material needed for just one of these critical elements. Let's take gallium, that's crucial for defense stuff, right? Like advanced radar.
Yes, gallium is a perfect example. It really highlights the industrial scale challenge. So to produce just 100 tons of high-purity gallium, which is roughly 10% of the world's output, the upstream supply chain needs to process 15 million tons of aluminum oxide feedstock.
15. million tons for 100 tons of product. That's almost unbelievable. Why so much?
Because the amount of gallium in the feedstock is tiny. You can only extract about 7.3 grams of gallium from 1 ton of aluminum oxide.
7 grams.
So yeah, to get your 100 tons of gallium, you need this gigantic super factory designed just to process 15 million tons of aluminum oxide every single year. The cost, hundreds of billions of RMB, easily.
Okay, setting aside the crazy construction costs for a second. What happens to the other, 14,999,900 tons of stuff after you scrape out the gallium?
And that's the economic trap. This process doesn't just make gallium, it makes a massive byproduct. About 7.5 million tons of electrolytic aluminum. Now, if you can't sell that huge amount of aluminum, and remember, the global market's already kind of flooded, China alone makes 45 million tons a year and struggles to sell it all.
Right.
Then the cost of producing your tiny bit of gallium becomes astronomical. You're stuck with millions of tons of aluminum nobody wants, making the whole operation commercially dead unless it's massively subsidized by the state.
That's a huge anchor weighing down the economics. And we haven't even touched on the power needed to run a factory processing 15 million tons of anything.
Oh, the power requirements are just staggering. About 75 billion kilowatt hours per year.
75 billion kilowatt hours. How much is that?
To put it in perspective, that single factory, it would chew through roughly the entire annual electricity output of China's Three Gorges Dam. The whole thing.
Wow.
If the U.S. wanted to power that kind of facility conventionally, you'd need to build something like 10 standard nuclear power reactors. Just for that one plant. 10
nuclear plants?
Yeah.
Just for one raw material factory. Given the U.S. hasn't really built new nuclear capacity in decades.
Yeah.
That's a multi-decade system-level commitment, way beyond just a business plan.
Exactly. And that's before you factor in the environmental compliance costs. Processing rare earths involves nasty stuff, strong acids, radioactive elements. In the U.S., with strict regulations and high permitting costs, that adds another massive layer of expense, which is why chasing self-sufficiency often becomes less about smart business and more about sheer national will and long-term political commitment. It's just fundamentally very, very hard and expensive to replicate.
Okay, let's take a quick pause here. If you're finding this deep dive interesting, drop a comment right here on China Gateway. Let us know what space you're in. EVs, robotics, clean tech, consumer electronics. Tell us below so we can maybe tailor future discussions. So the systemic costs are clearly enormous, but, a lot of listeners might remember, the U.S. did try to tackle this already, right? After China restricted exports to Japan back in 2010, there was that big push to restart domestic production. What actually happened when the money flowed?
Right, that was the whole Molycorp saga, centered around the Mountain Pass mine out in California. They raised and invested, I think, about $1.3 billion. They built this facility that was supposed to do everything: mining, processing, refining. The political backing was definitely there.
Okay, so the money was there, the will was there. What was the operational reality?
Well, honestly, it was kind of a disaster, and it really proves that just throwing money at the problem isn't the solution. Molycorp tried using a new, supposedly greener processing method, but it hadn't really been proven at industrial scale. When they finally did ramp up, well, the purity of their final rare earth products wasn't good enough. It just wasn't meeting the specs needed for advanced applications.
So unusable material, basically.
Pretty much. And on top of that, their operating costs were way too high. Their production efficiency, less than half of what their Chinese competitors were achieving at the time.
Ouch. Half the efficiency and lower quality output. That sounds like a recipe for failure, regardless of any political support.
It absolutely was. Within about 5 years, by 2015, Molycorp filed for bankruptcy. They'd bring through an estimated total of $3 billion. And the final kicker. The ore that was being dug up from Mountain Pass, it ended up having to be shipped, unprocessed, back to China anyway for refining.
No.
Yeah. And eventually, the mine itself was bought by a Sino-American consortium with backing from China's Shenghe Resources. So the big push for independence actually resulted in the asset falling even further under Chinese influence.
Okay, that brings us to the really deep question then. If it's not just about money, clearly, billions were spent, and it's not strictly about the technology, because presumably we have smart chemists. What is the deepest barrier? What's really holding back non-Chinese production on a large scale?
I think the sources we looked at really point towards one thing. It boils down to national will and the overall system structure. Rebuilding an entire complex, integrated industrial ecosystem like this, it's not a short-term project. It takes something like 15 to 20 years of continuous state-backed investment and just sustained political commitment. You basically need the equivalent of 3 or 4 consecutive 5-year plans all focused on this goal. It can't just happen through market forces or policy tweaks every few years.
So it's that long-term, unwavering commitment, sticking with something that might be losing money for decades until you finally achieve the necessary scale and efficiency.
Exactly, and that commitment has to include the workforce too. Building this kind of capacity requires huge facilities, needing maybe 30,000 to 50,000 skilled industrial workers. Some observations cited in the material looking at other complex manufacturing situations suggest that hitting the required output in these specialized, high-precision environments, well, it's complicated by labor availability and skill sets. It might require a really massive, dedicated workforce investment, the kind the U.S. manufacturing base maybe hasn't seen in a long time. It needs the whole system pulling together.
Okay, so shifting gears a bit.
Yeah.
For the entrepreneurs and manufacturers listening right now, what are the practical takeaways? Given this challenging reality, what should they be doing?
Yeah, the advice has to be pragmatic, not driven by politics. 3 key things, I'd say.
Okay, what are they?
First, focus on the specs. Prioritize quality, reliability, and hitting the exact material specifications you need for your product. If, right now, the only material hitting that 5 nines purity you absolutely require comes from China, well, you probably need to use it. Your product's performance has to come first.
Right. Don't sacrifice your product for the sake of sourcing elsewhere if the quality isn't there yet. Makes sense. What's number 2?
Second, dual source and partner wisely. Look into partnerships with established Chinese suppliers. Develop robust dual sourcing strategies so you're not reliant on a single source, regardless of where it is. That's generally smarter right now than betting everything on a brand new supply chain that might take decades to fully mature and become cost competitive.
So, manage risk for today, build options for tomorrow.
Exactly. And the third point is about timelines. Scale realistically. Running a pilot might take weeks. Qualifying a new material or supplier could take months. But achieving reliable, cost-effective operational scale, that takes years. Don't underestimate the time, the capital, and the sheer effort needed to build a sustainable commercial operation that can actually compete against decades of established scale and accumulated know-how.
That's really valuable, practical context.
Okay.
Before we wrap this up, for those of you listening who are ready to take some action based on this, we do have a few resources that might help align with these strategies. Want our free starter kit for China supplier outreach? It includes RFQ templates and a first call checklist. Just comment SUPPLY below. Planning to maybe do business in China or test the market properly? Comment market and we'll send you over a step-by-step roadmap. And if you're already sourcing things like magnets, batteries, or other precision parts, DM us Chain and we'll share our qualification playbook with you.
Ultimately, I think this whole rare earth story really shows us that true, deep industrial advantage isn't just about having the raw materials. It's built on decades of cumulative, patient execution across the technology, the manufacturing scale, and yeah, that sustained political commitment. It's a marathon, not a sprint, and the infrastructure and the process know-how are often way more valuable than the rocks in the ground.
Thanks so much for hanging out with us on China Gateway today. If this chat sparks some new ideas or questions for you, definitely drop them in the comments below. And let us know what you'd like us to dive into next. Maybe supplier vetting, navigating compliance, or perhaps some real factory floor stories. Until next time, stay curious and stay connected with China Gateway.